Okay, I'm not going to actually solve an entire problem here with numbers, but I am going to kind of draw out an FBD for a crazy problem that might help you on some of the trickier board battle problems. I'm going to make this really big so we don't mess this up. But so you have a big inclined plane here at some angle. We'll call this just theta. And so I have an incline here, or an object here. And let's say this is like a mower, and there's a handlebar here where someone's pushing the mower with a force of F1. But someone is also with like maybe a rope pulling the mower with a force of F2. Now we need to resolve these, of course, and onto our X and Y axis. So this would be a force up the incline and a force out of the incline. And this would be a force actually into the incline and a force up the incline. And let's do these angles. Let's say this is theta 2 and this is theta 1. So this side over here would be F1 times the sine of theta 1. And this would be F1 times the cosine of theta 1. This would be F2 times the cosine of theta 2. And this would be F2 times the sine of theta 2. So those are some of our forces on our FBD. We would also have the ever popular normal force. We would have a force going down in, which would be mg cosine of theta. We would have a force, I'm going to try to make room here, so we'd have a force going down this way, pretend that's on the dot, of mg sine of theta. And if this object is going up, we'll assume it's going up. That means we'd have also a friction force going down. Okay, so this is kind of a nightmare FBD. And we have to figure out, okay, what is this thing doing? Maybe we'll say, just to make it easier, we'll say it's going up the inclined plane at a constant velocity. Well, what would that mean? Whoops. Let's see. How do I get my eraser? My eraser? Yeah, I got an eraser there. Okay. So let me get rid of this part of it so I can write some stuff here. So if this is going up at a constant velocity, that would mean I have an up force here. I have another up force here. I have a down force here. And I have a down force here. And if this is a constant velocity, let's make this really difficult. Let's say it's accelerating upwards. If it's accelerating upwards, that means this force plus this force should be greater than this force plus this force. I should have a net force in the up direction, right? So I'd have a really big equation here. I'd say F net would equal F1 cosine of theta 1 plus F2 cosine of theta 2, subtract out mg sine of theta, and also subtract out force of friction, which of course would be mu normal force. And F net, of course, then is ma. So if I rewrite this equation, watch how ugly this can get. F net would, I'm going to do it clear over here. Ma is F net equals F1 cosine of theta 1 plus F2 cosine of theta 2 minus mg sine of theta minus mu. What is normal force? Look at this. Look how bad this is. What's normal? What's this force right here? Well, we have no acceleration in the vertical direction, so what do I have? I have a normal force going up. I have F2 sine of theta 2 is going up. I have F1 sine of theta 1 going down. and I have mg cosine of theta going down. So what is Fn? Well, I'd have Fn, this force, and this force added together should equal this force and this force added together. So they should be equal to each other. So what I need is I need this force plus this force, subtract out this force, and that'll be my Fn. That's like crazy ugly. I'd have F1 sine of theta 1 plus mg cosine of theta minus F2 sine of theta 2. I'd put all that in for my normal force. So I have this really big, ugly looking thing, and I don't even know what we're trying to solve for or what we would do in the problem. We'd probably have givens and stuff, and you could start plugging givens in and figure some stuff out. But the idea is, any of these kind of lawnmower problems, you have to resolve all forces onto the x and the y's, and then figure out what things are balanced and what things are not balanced, so you can write a starting type of an equation. This would be a terrible, mean problem for me to put on a test or something like that, but there are a couple board battle problems in our book where we kind of do something like this, and it's just a good exercise to draw out an FBD, keep track of all the forces, and figure out what kind of a starting equation can you use for constant velocity, or if something has a net force and therefore is accelerating.